Hello and welcome, my dear grade 11 advanced students, to my channel Mathematics Made Easy. Today, for the coming Math Term 3 exam, we are revising from the FRQ Learning Objective 18, which is from the lesson sequence series and sigma notation. And the goal today is to investigate different types of sequences. We'll begin with a word problem, followed by questions on recursive sequence. Watch the video till the end. If you like the video and it is useful for you, don't forget to like, share and subscribe to the channel. Let me know in the comment section the doubts and queries and which video you want to see next on my channel. Okay, so let's begin this learning objective 18 where we investigate several different types of sequences with this very important and long word problem. So it has 4 parts A, B, C, D. We will be using the concept of sequence, we will be using the concept of explicit formula, and we'll also be using the concept of recursive sequence for solving this question. So I will do each part A, B, C, D one by one. Let's start with A part. Also, we'll read the problem nicely. Lease agreements often contain clauses that limit the number of kilometers driven per year by charging a per kilometer fee over that limit. For the car shown below, the lease requires number of kilometers driven each year must be no more than 15,000. So there's a limit on the maximum number of kilometers. Let's write maximum number of kilometers that can be drove on this car within 1 year span, that is 12 months, is 15,000 kilometers. Now there are some terms and conditions written on the top of the car. Let's see. There is 1699 AD of down payment. Down payment means it's like a flash payment. Then 399 AD you pay per month. You pay this per month for another 36 months. So can I say the lease is for a period of 3 years maximum? Okay. Now let's see what question A part is asking. So it is asking you to write the sequence describing the maximum number of allowed kilometers on the car at the end of every 12 months of the lease if the car has 1350 kilometers at the beginning. So let's write A1, A2, A3. Okay, I'm writing 3 values. Why I'm writing 3? Because it is for 3 years. So end of first year, end of second year, end of third year. So at the end of year 1, which is 12 months, 1350 plus 15,000. So this is how much? 16350. Okay, so I repeat quickly because there was some noise disturbance. So A1 is the amount that you pay for the lease after the end of year 1. So there is a 1350 kilometers that you are traveling, and then the limit is 15,000. So A1, A2, A3 basically denotes the maximum number of kilometers which are allowed. So this is the maximum number of kilometers. Then for A2 I use the previous one, 16350. These are the kilometers allowed after the end of the first year, and for the next year again a limit of 15,000. So total limit of kilometers 31,350 kilometers. Last A3 I again use end of year 3, that is the 36 months. I use the previous value, which is 31350, and for this third year again I have a limit of 15,000. So total is 46,350. I repeat, this part had asked you for the sequence which has the maximum number of kilometers. There's no cost involved. So can I say the final answer would be A1 this value, A2 this value, A3 this value? Yeah, because you have to give 3 answers for the 3 years. So this completes part A. Let's move to part B in the next slide. Now let's read part B. Here we need to write the first 4 terms of the sequence. Now we are on this part. First 4 terms of the sequence that gives the cumulative cost of the lease for a given month. Okay, so you need to give how much is the cost that the person is paying for a given month. Now this is not year wise, this is month wise. So let's go to the values which are written on the top of the car. So what is the down payment? Down payment means when you take a car on lease or you take it on rent, how much money you pay directly. So it's 1699 AD. Okay, this is the down payment, and after that you are paying 399 AD per month. Every month if you're using the car you are paying this much. So let's write the first 4 terms, I'm going to denote the cost C1, C2, C3, C4. What are they denoting? Let's write. This is the cost at the end of the first month, cost at end of first month. And how many months we are calculating? First 4 terms means cost at the end of um, every 4 month. Okay, you understand. So down payment how much? 1699. Then after the end of the complete month, 399. So this is C1 value. Add them, you get 2098. This is the value. Then for C2 means for the end of the second month, this was the down payment, and you add to this. Now 2 months means 2 times 399. Either you can do this, or I would suggest you a better method. Let's use recursive sequence because that is easier. So for C2 I will use C1, means I will take 2098, this is the cost at the end of the month, and then 399, just add, because you are again using it for another month. Every month you need to pay 399. What is this? Let's calculate. It will come out to be 2497. Then again for C3 I use C2. So 2497 previous term plus 399 for the new month. So this is 2896. Then for C4 again previous term C3 2896 plus 399 extra for the fourth month. So total is 3295. So let's write the final answer. So the final answer for B part, it has 4 terms, so we will write one by one. The first is 2098, then 2497, then 2896, and last is 3295. So that completes part B. Let's go to part C in the next slide. Okay, let's do the C part. In C part, we have to just give the explicit formula. Let's write the explicit formula. Now it is very easy because we will use the answer that we got in part C. So for answer C, we just need to give explicit formula, okay, to represent the sequence. Now if you see from the last part, the sequence was written in terms of the down payment, the cost, plus 399 for every month. So if there are n months, can I write the variable n? So this will denote my an. Okay, so if I want to calculate, now I can show you how to use it for part B also. So if I want A1, means I want the sequence, the value that gives the cumulative cost of the lease for the first month, just put N1. Do we get the same answer? Let's check. Yeah, 2098. If I want second month, just in the same formula, put N as 2. So what do you get? The same answer, 2497. So that means this formula is correct. It works. But yes, for C part only, this is the answer. I just use this to explain you how it can be applied. Let's go to the last part, D, in the next one. So in part D, you have to determine the total amount of money paid by the end of the lease. Now, when does the lease end? The lease ends after 36 months. So what is the time for end of lease? It is, if you want to say in years, it is 3 years. If you want to say in months, it is 36 months. Okay, and now let's write from part C what is the explicit formula. We got an equal to 1699 plus 399 into n. N is what? N is the number of months. So how many months I'm taking the car? I'm taking it for 36 months. So can I replace n with 36? Will I get my total cost? Yes, because an is representing the explicit formula to represent the total amount of money paid by the end of the lease. So let's put this value 399 multiplied by 36. Use your calculator. It's going to be 1699 plus 14364. So the total cost will come out to be 16063. So this is the final answer for part D, where you get the total money, amount of money that you pay at the end of the lease after 3 years or after 36 months. So that completes this question. It was a long but very important question. Let's do some more questions from this learning objective 18. Okay, let's solve question 12. This is on recursive sequences. How do you know this is recursive? because the first term is given separately and the nth term formula is in terms of the previous term. So if n term I'm taking, the previous term is n minus 1, the one before this. So whenever the formula for an is given in terms of previous term, you know it is a recursive formula. Also, there is a condition, n has to be greater than equal to 2, so you can start applying this formula from n equal to 2 only, not before that. Any which ways, a1 is separate, so if I put n as 2 in this formula, we get a2 as minus 3, previous term is a1 plus 10. Now a1 is given to you 5, put that value, solve, simplify, and this comes out to be minus 5. So we have got our a2. Next we will find a3. Which term we have to find? We have to find the fourth term, or a4. So I'm going to continue and repeat this till I get my a4. So let's get a3. a3 previous term is a2. I'm putting in this formula for an, the recursive formula. Put the value of a2, solve. So this is plus 15 plus 10, 25. Now apply for n equal to 4. So a4 is minus 3a3 plus 10. Put the value of a3, simplify. So this is minus 75 plus 10, so minus 65. Now what you had to find in this question, you had to find a4, which is negative 65. So if you see, this was a question on recursive sequence. We apply 3 times the same formula, an equal to minus 3, an minus 1 plus 10. First for n equal to 2, then 3 till 4. So this is how you need to solve the question. Let's do one more question. Here we need to find the third term. I need to find a3, a1 is already given to me, and the recursive formula for an starting from n equal to 2. So let's start applying. When I put n as 2, an becomes a2, which is given as square of the previous term. So if a2 I'm finding, the previous term is a1, there is square, and then minus 5 a1 plus 4. Let's plug in the value. a1 is given to be 3, so 3 square minus 5 multiplied with 3 plus 4. 9 minus 15 plus 4. So my a2 comes out to be minus 2. a2 is minus 2. Now we are ready to find a3. That's what we need. So I put n as 3. So a3 is a2 square, previous term, minus 5 times a2 plus 4. Let's put the value. I substitute in place of a2, minus 2. Simplify, solve, use your calculator. This comes out to be 10 plus 8, 18. So my final answer for this question for the third term a3 is 18. This is how recursive formula is used. Let's find the fourth term for this sequence. That means we need to find a4. So we will put n equal to 4. And also there is a recursive formula given to you. In this formula, the condition is n greater than equal to 2. So let's start with n2. Then we'll go to n3 and last for the answer n4. Okay, so when I put n as 2, let's see what I get. a2 is equal to 3 times. Now 3 is raised to the previous term. So to the power of 3, we have the previous term a1. So 3 to the power 0 is 1. Remember, any number raised to the power 0 is always 1. Now I go a3. a3, the previous term is a2. So 3 to the power a2. So 3 to the power a2 means 1 is 3. Then finally a4, this is 3 raised to the power previous term a3. So 3 to the power 3, which is 27. So your final answer for this question for a4 is 27. This is how recursive formula is applied.